Okay, let's get started. Welcome to this webinar on working with Overture data presented by Jennings Anderson. My name is Mark Prela. I'm the Executive Director of Overture Maps Foundation. Thanks for taking your time to be here. This is the first webinar in what we hope will be an ongoing series. Our goal for these events is to provide a venue that allows us to go a little deeper into technical topics, answer questions from the audience, and provide updates on what Overture is doing. You may know this already, but Overture Maps is an open source map data project. The project was announced last December when it was founded as a project under the Linux Foundation. We've been working on building open map data, primarily aimed at application developers, organizations which are building mapping and location applications for enterprise, government, research, and many other sectors. In June, we produced a schema, and at the end of July, the team released our first data product. Today's webinar is on that data release, what's in it, how to access it, and how to use it. Next slide. We have a couple housekeeping items. You should know that the session is being recorded and will be available later on YouTube in case you or someone else you want to refer wants to look at it later. Also, audio and video for participants is disabled, but we do want to get to your questions. You should see a Q&A button at the bottom of the Zoom page. And you can answer your questions there. I see we have a couple of questions already. And you can also upvote questions you'd like to see answered. We'll prioritize questions on the topic of this webinar, but we'll try and get to any questions that are in there as best we can. We'll have a Q&A session at the end of the talk where we can address some of those. Also, at the end of the seminar, there's a brief survey. It's really important to get feedback. We'd like to do more of these. And it's really important for us to know not just how it went, how effective it was, but also what topics you'd like to hear. So your feedback's valuable, and we'd love to get that at the survey. Next slide. Let's move along to the topic of the day. Jennings Anderson will be talking about the initial release of Overture data that came out in late July. He'll spend a few minutes talking about what's in the data, and then most of the time looking at how to access and use the data to build maps and location applications. We have some Q&A planned at the end of the session, and I'll be watching the questions as they come, and we may break in and cover some if that seems appropriate. Again, you can ask any questions about Overture. I'll prioritize the ones related to this topic and cover the others as the time allows. Jennings is a research scientist at Meta. He's been conducting research in open geospatial world for the past decade, primarily studying the evolution of OpenStreetMap over that time. He frequently collaborates with other researchers in this domain to answer questions about data coverage, quality, and community dynamics. Recently, he's been working closely with the Overture Maps Foundation to design the data schema and get this first data release published. I'll just mention on a related note, Jennings has recently done a podcast with the Mapscaping podcast, a really excellent podcast on mapping and related map topics. Just came out this morning. We'll add the link to that in the show notes, or you may want to search for it wherever you get your podcasts. We'll keep this webinar to about an hour. And without any further, I'll turn it over to Jennings. Jennings, take it away.
Excellent. All right. Thanks, Mark. I'm really excited to be doing this today. Before we get started, I want to make everyone aware of the following 3 resources. First, we have the documentation at docs.overturemaps.org. This is where we describe the data schema for Overture data and discuss some of the decisions around the themes and how they are organized. And then we have 2 GitHub repositories, the data repository as well as the schema repository. The data repository is a great place where we can open issues and discussions around the data itself. And then the schema repository actually holds the data schema and is a great place to have discussions around the Overture data schema. So I will be referencing these extensively today. So I want to make sure that everyone is aware of these repositories. So today we'll be going over the most recent Overture data release, and perhaps more importantly, why there isn't a simple download all of the data button on the website. This first release contains data for the following 4 themes: administrative boundaries, buildings, places, and transportation. You can learn more about each theme and their individual data schemas in the documentation. Today, I'm going to first go over what exactly is in each theme, where it comes from, and we'll dig into some data. It's my hope that by the end of this webinar, you'll find that while there isn't a single download all of the data button, this initial data set is relatively easy to work with, and you are able to examine, extract, or otherwise manipulate the data right here in the cloud through your browser, and then download only exactly what you want. First, administrative boundaries. There are 2 distinct types: locality and administrative boundary. Together, there are just under 100,000 features representing admin level 2, primarily country boundaries, and admin level 4, which are state and regional boundaries. There are 785 million buildings from OpenStreetMap, Esri Community Maps, and Microsoft in this current data release. Nearly 30 million of these buildings have height information, with at least 10 million of those height values being extracted from USGS LiDAR data. Overture conflates these 3 data sets by first taking OSM as the primary data source. Since buildings from both Esri and Microsoft ML datasets are consistently being added into OpenStreetMap via tools like Rapid, we set OSM as the primary source so that we're always prioritizing that human-validated building footprint. If Esri community datasets have buildings where OSM doesn't, we then add those buildings. And finally, we fill in the rest of the map with any ML-derived buildings from Microsoft. Now, this first data release only includes Microsoft buildings for a few countries, but future releases will be global, so expect this total number to climb well over 1 billion. There are nearly 60 million place and points of interest features in the Places theme. These data are from both Microsoft and Meta, and we'll dig deeper into this layer in a minute. Finally, transportation is split up into segments and connectors. Currently, the data comes from OpenStreetMap and is resegmented so that the connectors always and only exist where 2 or more segments come together. So let's dig in. Today, I'm going to use Amazon Athena as an interactive query environment to read Overture data. Using Athena is just one way to access the data, and the instructions for how to get started are available in the data repository on the Overture Maps GitHub, as shown here on the right. Using Athena does require having an AWS account, and you will be charged based on the amount of data scanned. However, given how the data is organized, the amount of data scanned is very minimal. Overture data is hosted on both Amazon S3 and Microsoft Azure Blob Storage. You do not need an account with either of these companies to access the data, only if you wish to use their tools such as Athena or Synapse to write queries against the data in the cloud, like we will do today. DuckDB, on the other hand, will allow you to run similar queries against the Overture data from your own machine, so no cost will be incurred. It will, however, be slower because your local machine will have to download bits and pieces of all these files, which are intended to be read in a distributed environment. So for simplicity and consistency, today I'm going to demonstrate the Athena approach because these cloud-based queries will be faster than DuckDB, making it feasible to actually do them live here in this webinar. So let's get started with the places data. The next few slides are going to include SQL, and there is a file in the data repository called webinar queries that contain these queries exactly as they're written on the slides if you'd like to copy and paste and follow along or reference at a later date. So let's get started. I'm going to hop over here to my Athena console and my query editor. Now, I have already run the setup instructions. So you'll see here I have the 4 Overture tables loaded here on the left. So let's first just take a look at the places data. And I will hide that so we can have a full screen here. And now we're just going to count the data in places. And we see that we have our 59 million places. So it looks like we are connected. So let's take a look at what actually is in this data. Now we'll look at just the top 10 records. The first column here currently contains a temporary ID. Eventually, this column will be an entity ID from the Global Entity Reference System, or GERS. GERS will provide stable and unique identifiers for Overture data, and I'll share a bit more about GERS at the end. Then we have some metadata, such as the update time and the version for the current data release. And then we get to the data here, like names, categories, and then this confidence value. Now let's hop over to the documentation and read about what these columns actually hold. Oops. So looking here in the documentation, I'm on docs.overturemaps.org. I'm going to go down to the place type in the places theme and take a look at what these properties are. We'll see that names here is going to be an object containing common, official, alternate, or short names for the feature. Common is required, and inside of it is going to be other objects that include the value and language. So if we go back to names here, we see that we have the local language value for the name of all of these places. Looking at other fields like categories, we see that there's a main and an alternate category. And then we get to this confidence number. We see here in this top 10 data, we have confidence values ranging from 0.25, looks like all the way up to 0.9. So confidence is the confidence in the existence of the place, a number between 0 and 1, where 0 means we're not sure the place exists anymore, and a 1 means that we're sure that the place does exist. If there's no value for confidence, then there's no confidence information. Okay, moving on, we have a couple other fields here: websites, socials, emails, phones, brand. Again, these are all listed out in the schema. So these are all the contact information for these places. And then we get to sources. We can see here that the majority of this data has all come from Meta, and we have a little bit of metadata about the sources. If it came from Microsoft, it would say Microsoft in here as well. And then we have some geographic metadata, the bounding box, and then the geometry. The geometry in the Overture Parquet files is stored as well-known binary, which is great for the computers, less great for us to read. So we can just turn that into well-known text. And run that query again and take a look. Scrolling over here, we now see the point representation, and we should expect to have all points here in the places theme as consistent with the documentation. Geometry type is point, and the geometry object, GeoJSON point here. So let's go back to this confidence value. We saw that just in this top 10 data, we have confidence ranging from 0.25 up to 0.9. So I'd like to do another query here to get a better idea of the confidence distribution across all of the 59 million points. This query is just going to group the confidence round it to the nearest 10th, and then count the percentage of data that exists. So we see here that 12% of all of the places data does round to a confidence value of 1. And then it looks like rounding to a value of 0.9 is about 14%, and 14% as well for 0.8. And then we can see the rest of the values here. So what I want to highlight here is that we're able to run this query, generate this table in just a few seconds without having to first download and process any of this data. And then again, these are the queries we just ran. However, we are talking about spatial data here. So let's take a look at what type of spatial coverage we have in the places theme. This particular query is going to group the data by the zoom level 8 map tile. and then count the number of places that exist on each tile. So the query is run, it has returned the polygon of the tile with the number of places, and we can go ahead and download those results. And now I'm going to load that CSV that just downloaded directly into QGIS. So it's a CSV. I will add a delimited text layer. Look at my last downloaded file. It's going to automatically detect we're working with well-known text. Add that to the map. And now we see global coverage. I'm gonna style this now real quickly. Let's quickly do a log scale based on the number of places. Equal interval. Let's choose something like that. Maybe a couple more classes. Okay. We can also just go ahead and add a quick filter on here. Okay, so all we've done is we took that CSV directly from AWS and loaded it here into QGIS. We went ahead and styled it based on the number of places in each of these tiles. And then we filtered for only tiles where there were more than 5 places. This query only included data, I believe, above 0.8 confidence. And we can see that we do have pretty expansive global coverage. We also kind of see our little bit of our population map popping out here, where we have our cities with more places. So we can see that the places data does have here pretty good global coverage. And that was just an example of pulling, doing some kind of quick analysis, grouping it by tile in the browser, and then just downloading exactly what we wanted to see here. So that's a quick form of analysis, but what about actually getting the data? So now let's download some actual places data as a CSV in a similar manner using Athena. This query, we're going to get the category, the main category as the category. We're going to download the confidence value. And we're also going to get the geometry again as WKT. And this top part, what we're going to do is only extract that value for the name in just the local language for this particular data set. And I've added a bounding box here, which is vaguely the Pacific Northwest of the United States. And now we see that we've returned 200,000 rows here, 200,000 features of all different categories. And here's the name and the geometries. Again, I will just download those results. And then a nice tool for quick visualization is Kepler GL. And I'm just going to drag and drop that file directly in here. And there we go. Here are our 200,000, take a look at them. Name, category, confidence. Here are 200,000 features in the Pacific Northwest from places. We can quickly look at this. If we add a filter on confidence value, we can kind of move that up. Looks like that cleans up the data a little bit more there, looking at only confidence values above 0.98. We can see here all the data around Seattle, name, confidence, etc., all right here using Kepler to visualize. But again, all we've done is download a CSV. Now, if I want to put this CSV into a tool like QGIS, I want to be a little bit more careful because 200,000 points is going to be a little bit slower as just a CSV. So let's go ahead and use a tool like GDAL to convert that CSV directly into a shapefile. So I'm going to grab this file we downloaded. Just going to rename it here to places.csv. And then let's just go ahead and run Ogre to Ogre. And here's our places shapefile. Drag and drop that right into QGIS. And again, we see our places data for Seattle, and we can kind of see the density corresponds here to the color of the number of places as well. So now we could also query here for, we only extracted a couple of these columns. We could also add our websites, phones, etc., and pull in whatever other types of data you would want to view here with your places data. Okay, so now that we have our places data, let's take a look at some buildings. Let's start by doing a very similar analysis of looking at the buildings coverage globally. And we'll do the same thing here, grouping by zoom level 8 tile. And I'm curious, we were talking about how we conflate data from OSM, Azure Community Maps, and Microsoft ML buildings. And so let's look at whether or not OpenStreetMap exists in the sources for these particular buildings. So this is the query we will use. And then again, we will just count the number of buildings in each map tile. This is going to take a second as it's counting 785 million buildings. Okay, and then we'll download those results. And I'm going to go back to Kepler here. And drag and drop that data right in. And we have our global coverage. I'll style this quickly so we can see what we're working with. Use a diverging color scheme. Make sure that that's quantized. Maybe a couple more. Okay, so now we can see here, these are the countries where we have these countries here where the data tends to turn more blue. We have a lower percentage of OSM, and meaning there are more Microsoft ML or Azure Community Datasets buildings in that tile than OSM buildings. And you can see here the countries that currently have Microsoft ML buildings added to them. However, this doesn't quite tell us about the total number of buildings. So let's go ahead and add some height to this just because we can. Scale that up a little bit. Now we're looking at kind of a global analysis of the building coverage right here in Kepler from the CSV that we downloaded directly from Athena of the number of buildings available in the buildings theme. You see we have more OSM buildings over here in Europe and Southeastern Asia. And then we have more data coming from in more of these blue squares, data coming from Microsoft ML buildings. So, okay. Now that we've kind of looked at the global building coverage, let's go ahead and download some actual building data to play with. So I've gone ahead and traced out a quick kind of polygon just around Seattle here as an example for this query. In this case, we're actually going to do a spatial operation of only getting the actual building geometries that are contained by this polygon. So here's the polygon around Seattle, and then we're going to be using the geometry of the buildings theme to actually make this comparison. And in buildings, we'll be taking the class and the height value from the buildings table. I'll copy that. Now, while we wait for this, let's go take a look at what this class value represents in the Overture data schema. We'll see here that class is a broad category of the building type or purpose. Possible values: residential, outbuilding, agricultural, commercial, etc. And these are coming mostly from the building tag in OSM or in the Esri community datasets. And we'll download our results. It's found nearly 11,000 buildings in that area. I'm going to put the CSV. We can take a look at it. We have the class, height information, and the geometry there. Now let's go ahead and convert this into something a little bit more spatial. Same thing. I'm going to use GDAL here to convert it to a GeoJSON. And now we have our GeoJSON file. And then we can go ahead and load that into Kepler. I'll just do that again just to show you. Here's our buildings.geojson, loaded again right here into Kepler. Turn on height because we do have height values. Let's go down. And then also we have our class. And if we choose kind of a random color palette like that, we can see that we are able to differentiate between the different class values that have come through in the buildings. So for example, these pink values are class medical, and we see them around the medical center here. And then these more kind of brown are commercial buildings. So this kind of shows the coverage that we have for our class values. So that is downtown Seattle. Now, let's convert this one more time. Oops. Since we have this GeoJSON file of buildings, let's use Tippecanoe to create tiles, in this case at zoom level 13, for this building's layer. Now I've just created this PM tiles archive. And we can use the PM tiles viewer. And again, just another view of that data. We're able to create tiles directly from that GeoJSON that we converted from that CSV from Athena. So here again are all of the buildings in that area that we queried for. So now that we have places data and buildings data, I'd like to show you an example map that we made from this Overture data built using the same methods that I just showed you today. So this looks familiar. Here are our downtown buildings, again, colored here by class. We're gonna have our commercial buildings. And this was made exactly the same way. We pulled this data using Athena and then turned it into PM tiles and styled it. We also have the places data in here as well. And then we've gone ahead and done the same thing for the roads layer, or for transportation. There we go. Here are the roads. Roads, buildings, and then again, all that places data. So we are missing, however, a little bit more context to create a full base map. So we can also add in land and water and place names. This is all data coming from the Daylight OpenStreetMap distribution. And now we have something that looks a lot more like a base map with all of the Overture data right in it. Okay. Still no download button. So I wanted to show that Athena was just one way to access the data. Today, we're able to transform, download, analyze all the data in the Overture data release without needing to first download and process a massive file. However, if you must download all of the data, the Parquet files are available, again, on S3 and Microsoft Azure. So if you want to download those and put them into your own environment, or just look at them locally, that's absolutely available. I believe the entire data set is about 200 gigabytes if you download all of the Parquet files. But I hope that I've really made the case today that by releasing the data in these Parquet files, Overture has enabled users to obtain the data in any format of their choosing. For example, today we've seen Overture data go from Parquet in the cloud to local CSV, GeoJSON, shapefiles, and even right into map tiles that we're able to render. Next, so what's coming next? Future releases will continue improving in coverage and quality on the existing themes. So for example, we saw today that the buildings theme does not have Microsoft Buildings coverage for all of the countries globally, but expect that to improve in coverage in the next release. And the global entity reference system, which we mentioned briefly, this will assign stable IDs to features across these 4 themes, allowing the matching of external data sets and then also easy ID-based conflation. So stay tuned for the release of the Global Entity Reference System, or GERS as we're calling it. And with that, happy to move on to a Q&A, and hopefully we can, we can answer some questions.
Thanks, Jennings. We have about 20 questions. I'll try and go through them in sort of the logical order, but and try to get through them all. Jennings, there were a lot of questions about the confidence scores on the places data, and maybe if you'd say a few words about what those confidence scores indicate, how they're calculated, and some thoughts on how someone would use them.
Yeah. Thanks. So as we saw in the documentation, right, confidence 0 means that the confidence is that not that it's not a place, but rather confidence 0 means that we're sure that that place no longer exists. And so that can be kind of used as a negative signal, if you will. Knowing something about that place is knowing that it no longer exists at that location. On the other end of that is confidence level closer to 1, meaning that we know exactly that place exists. There has been a lot of kind of ad hoc analysis out there about this confidence score. I believe there's a great blog post out there that is comparing, I believe it was in Brazil, looking at the confidence values, someone out and ground truthed it all, and saw that this confidence value does map pretty well to reality. And I think that you just need to look at that confidence score and compare kind of define, we used 0.8 as just an example value. But I think you can explore within that confidence score what level you're comfortable with for your use case. But what we wanted to release was all of the data with all of the confidence values, so that we're not making an opinionated decision on what data is going in there, but we're rather giving the full signal. So that is I think a lot of people saw the places data and said this is really messy, and that's why the confidence value is there, is to allow you to kind of set your threshold for places data. And this data will continue to improve moving forward.
Thanks, Jennings. One other question was about what factors were taken into account with the confidence score. I can answer that. I think primarily there are obviously many factors in there, but the primary ones are like high likelihood of interaction through social media check-ins, and also corroboration with third-party sources was one of those were kind of the two main factors. This data set was put together from combining two data sets, as Jennings mentioned, and so that to the extent those reinforced it, the confidence score was moved up as well. As we go forward and add more sources, you would anticipate those confidence scores becoming stronger and more robust as we go on that. Jennings, maybe you want to answer, what is the value of a low confidence place record? Why is that a valuable piece of the data set?
Yeah, I think that, again, there's a difference between knowing absolutely nothing or knowing that place no longer exists. And so that could be used as a signal if you're matching to other data sets, for example, and trying to compare. This is still a signal, a confidence value of 0, meaning that place no longer exists at that location. And I think that can be a very valuable piece of information to know that there was a place there with this information, but it no longer exists at that location. So I think that's the value of that very low confidence score.
There's another question here that talks about, can you share a roadmap with how you expect this to improve, when it'll improve? And I think if I infer from what you said there, Jennings, we'd expect to continue to have records in there with low confidence scores, because those are useful if you're, to know what might have been there, or maybe corroborating low confidence scores with higher confidence scores to build more confidence overall. Longer term, from an Overture perspective, we hope to combine more sources into the places database. And as we get that, you get a couple of things. One is more sources means more corroboration for those sources. But the other is, if we can combine sources that are created in different ways, we start to triangulate on better and better places data. And I think that's sort of where the roadmap is headed on that.
One more point on that, Mark, is that, again, that's the value of releasing the data in these Parquet files as we have, is that just because the full corpus includes those confidence values going from 0 to 1, if you are not interested in knowing what places are no longer there anymore, and you just want data above a certain confidence value that you feel comfortable with, then you can go ahead and add that into your query when you extract this data. And you are getting just, again, the data that you are looking for, not the entire corpus.
Jennings, we had one question in here that I know was asked when we released a lot. Why not geoparquet? Great
question. So this first data set, the way we generated the Parquet files, we didn't necessarily have an option to create the geoparquet metadata required to be valid geoparquet. So we released this data. These Parquet files look very, very close to geoparquet. We wanted to be close, but not, unfortunately, we don't have that exact metadata. So we have, for example, the geometries are in 1-1 binary. We do have bounding box information at the feature level. And there have been some other examples of people taking these Parquet files and then converting them into geoparquet. And as we move into future releases, we will look at ways we can release data, hopefully in geoparquet as well. One reason that we wanted to get some data out there so that people could look at this. Could we release the schema? And we wanted to then put data into the schema and let people start exploring the data and see what's out there. One open question is, if we do generate geoparquet files, what type of a partitioning scheme should we use? Should these be country level geoparquet files? That makes sense for some things, not as much for others. So thinking about how we partition the data one step further is kind of an open question. And I think that it also brings up this idea of Overture as a map data just as a map data provider, not a map service provider. And so I think that by releasing, again, we haven't made too many of these opinionated decisions about how the data is released, but rather putting everything out there in a format that allows people to pick and choose exactly what they want. So we kind of stay at that high level of these Parquet files, and then putting the data, into geoparquet files partitioned by some extent is making one opinionated decision. So we do understand absolutely the value of geoparquet and new tools that are supporting those more natively. So future releases, hopefully we will be looking into how we can get something that is more compatible with exact geoparquet. But for now, we've released something that looks very similar, trying to reduce that friction. If somebody wants to put it into geoparquet, that should be very, very straightforward.
Thanks, Jennings. There's a couple questions here on update cadence, both specifically for POI data, but generally. And just to say a word on that, our initial goal for update rates on Overture data will be a monthly release, and we'd like to move that to weekly releases as quickly as we can. When we released the data in July, we labeled it an alpha, and one of the main reasons we labeled that as alpha versus production is we had not yet set up a cadence where you would get the next release in a predictable amount of time. But we hope this fall to start releasing on a monthly cadence, and then our goal is to fairly quickly move that to a weekly cadence. So that's something I think you can look for in the next few months. So hopefully I answered a couple of those questions there. Let me, Jennings, go back to you. This is a question from Justin Myers on multiple. Let me just read it. Is there going to be a comparison between multiple building data sets to create a new unique building footprint data set? So for instance, you mentioned several data sets we had there. How are you thinking about that?
Yeah, this is a really great question. We are, as we kind of described in that, in the looking at the buildings data, we do currently conflate in the order of OpenStreetMap, Esri community data sets, and then Microsoft ML buildings. So we are making that kind of opinionated decision as we go through that conflation. Again, always taking OpenStreetMap as this primary source. And I saw another question in there that said, how do we add height information? That is another good way to get data to flow into Overture. Buildings, for example, will always take OSM as the primary source for now, so that height information can be added into OpenStreetMap, and then will be improved in Overture. So initially, that's how this conflation order works, and so that's creating that kind of one unified data set. However, as we look into systems like GERS, that is a huge advantage where we can then apply these unique IDs to all of these buildings. And you could then, you could see how you could then do your own conflation, comparing these buildings with different IDs or with the same ID across different data sets, and kind of making your own decisions there on what type of building you'd like to use in your own data. So that's how we currently do the conflation. And then I think it does open the door for what you could do with tools like GERS that enable conflation.
Jennings, let me ask a question come to a question that I think is related. It says, will attribute data and geometry data be conflated across sources? For example, the building from Microsoft and the name from OSM. If so, will we be able to see the source at the attribute level?
Yes, exactly. That's why sources, if you look at the schema, sources is an array that allows you to actually put a source level. We have, attribute level sourcing. So we are already doing this for a number of buildings where we then apply the height as extracted from USGS LiDAR. You'll see that it might say the height, the building footprint itself is from OpenStreetMap, where the height attribute is coming from USGS LiDAR, or the building itself is from Microsoft ML, and the height is coming from USGS LiDAR. So the schema does enable this kind of attribute level attribution and source distinction. So yes, that I think is a great question.
Okay. Jennings, there are a couple of questions here on administrative boundaries, and could you talk about the levels we have and plans to go particularly to a city level?
Yeah, I think that's exactly what it is. We currently have the admin level 2 and admin level 4 going for country and kind of region state. And this is just one of those data layers that we hope to improve moving forward. And by improve here, we just mean expand and offer more levels of administrative boundaries, hopefully going down to city, regional, township, etc.
And there's, I think, a related question on that, which is, and it maybe ties into GERS, is will there be a unique ID for a city and its boundaries?
Yes, and this is what GERS will hopefully is working to solve, is how can we assign that for different boundaries, and then be sure that we can relate these admin boundaries to each other, and that is what GERS will enable us to do. So yes, there will be in the sense that the concept of a city and the boundary of a city is an entity. There will be a reference to that entity in the global entity reference system, which is something we're very, very excited about.
And here's a cultural question for you: is it Parquet or Parquet?
That's a great question. I just saw that.
My
I've
French
heard Parquet.
ancestors are going to say Parquet, so we're going with Parquet. Okay, there are a number of questions. One question in here is about addresses, and I think, sorry, I'm scrolling. I can't find exactly what it is, but I think what the question is would we be looking at an address data set distinct from the addresses that obviously come in places? My answer is yes. Clearly on the roadmap, clearly an important part of map data. It really is just a bandwidth and sort of getting things done with the number of folks we have. So addresses is obviously important. There's a lot of good sources of open addresses, and it's clearly something we're thinking about there. Let's see. Let me ask a question about validation and Microsoft. The question is, how are Microsoft ML buildings validated?
Yeah. So right now, we're not doing additional validation on the MS buildings. We're filling in the map where we don't have data from OSM or Azure Community Datasets, and kind of filling in with this MS ML building layer at the end. I think that this is an important, as we move forward and think about this, I think that there will always probably be this kind of bottom priority and conflation that will be the kind of ML building footprints. There's a couple other sources out there. There's the Google Open Buildings data now. So I think there will always be that kind of going for coverage at the end, at the lowest priority in the conflation. Now, when an MS building makes its way into OpenStreetMap via Rapid or something, that has gone through that human in the loop process has clicked accept this building footprint, and now that is an OSM building, and so now that will always take priority over other ML derived data sets. So that's kind of an important distinction of there are many buildings that have been added that have then been validated, and that's how they're making their way back into the data, but that's actually via OSM. So I think that that's a very important loop to be considering.
Jennings, just related to that, there was a question here about adding data and individuals contributing data and when that should go to Overture versus when that should go to OSM. Do you want to just talk about, like, if an individual sees something in the data and wants to change it or improve it, what would you recommend?
Yeah. So the Overture data set, and I believe I described this, tried to describe this on the podcast, the Mapscaping podcast as well. I like to think of it as kind of being downstream, and OpenStreetMap is just one of the many data sources coming in. And so if the source data is OpenStreetMap, then that's something, a change in OpenStreetMap will flow into Overture, where that data is coming from OSM. The OpenStreetMap being then the primary source for community driven, community maintained data sets. And so that would be a great place to go and update and fix data in eventually in Overture.
One thing, just maybe there are a couple questions here on licenses and things like that. So maybe I'll just say a word about that. When we release the data, each data theme or layer has a specified license, and the two primary ones are ODBL, which is, as you might know, the primary license, or the license for OpenStreetMap, and CDLA permissive version 2.0. It's important to understand the implications of each of those licenses because those licenses do carry through with the data. So, for instance, our transportation layer, which is our roads, is primarily a OSM layer, and it carries the ODBL license with it. Any changes, modifications are required by that license to be shared back, and that's an important distinction to make on that. So the license comes through with the layer. There's a pretty significant body of work, and there's descriptions of what is a derivative database, which would require sharing back versus a collective database. And I refer people to that. Other layers, like the places layer, is licensed under the CDLA license. And that is a more permissive license. It can be changed and modified, and changes do not have to be shared back. So it is layer by layer, and you need to pay attention to that as well.
The buildings layer also is a great example of ODBL, where it's taking again OSM as primary data source, and then adding these other data sets in. So that whole theme, that whole layer right now is ODBL.
Yeah. Jennings, I'll ask this question. There was a question about ADAS that a lot of people upvoted. The question, let me read the question, then maybe expand it a bit. It says, my project involves navigation systems for in-vehicle ADAS applications. Would Overture be applicable to ADAS applications? And you could either answer that directly or talk more broadly about how GERS allows data to be added onto the base maps.
Yeah. So this is, I think, really the hope of GERS and how it's going to enable, right? If we have this particular unique stable identifier for all of the features in the Overture data set, that means that we're going to have, for every segment of road, is going to have a unique identifier, and then also with OpenLR and linear referencing, be able to reference very specific pieces of the transportation network. And so our hope with that is other data providers, if they don't want to add all of their data to Overture, and many data doesn't necessarily make sense to add that directly to Overture. If you're, say, a traffic provider, and you have information about a particular segment of road, you could then be publishing that stream with that GERS ID, and anybody else who's using Overture registered data will also be relating to that particular GERS ID. And so we see this as a way that anybody can match their data to the Overture corpus via this unique GERS ID. And again, the promise there with GERS is that we will try to be stable across releases. These will be stable identifiers. And where we can't be stable, we will also be traceable. As things change, we will update and show what has changed. So that's the hope there with GERS, is that it will enable external data sets to match to Overture, and then using that as a common reference for many geospatial data sets.
Great. I'm going to, we've got a few minutes left. I'm going to try and focus on ones related to the topic here. Is there a way to use download the Parquet files option for downloading, but then also specify a region instead of the entire data set? So you mentioned you could download the Parquet files. Can you do that just for a certain region?
Certainly. So you could, yeah, you'd have to run a query against the data that would specify that region, and this would be a great case for DuckDB, for example, is able to connect to the data sets, run that query, and then produce the output file in any format that you would hope for. I think I saw that question as well, and it referenced this idea of a map. Again, as like a map service. And I think that's where I want to make that distinction, that the idea of releasing this kind of this data set as Parquet is that it opens the door for, again, this is the map data, it opens the door for map service providers to build tools on top of this data. And so that is another example where offering a tool that takes that data, slices and dices it, and creates regional extracts is something that we want to encourage users of the data to go out and build those tools and use those tools. And as we improve, as we have future data releases, we'll also be looking at different ways to organize that data to enable more of those use cases and enable those those desires.
Great. I'll do a couple of these. One question we got upvoted a lot is the road network good enough for navigation purposes? I would answer that by telling you that the transportation layer that we have is primarily based, it is based on the OpenStreetMap data. It's been put in the schema, but the underlying data is primarily from OpenStreetMap. I will leave it to you to decide if that's good enough for navigation. I think it's being used for navigation for a number of places, but I think that would be one I would leave to you. The other question, and I think there were a couple of these, is will there be an API from Overture? Our current plans are to build data and release data in these cloud native formats that we've been talking about. We don't intend to build an API. Having said that, I think there will be APIs offering Overture data. I think what we've seen is a pretty good ecosystem of people who do want to do that. So I think that will you will see that, but we don't plan to do that. Will you provide more tutorials and examples? Yes, we're hoping to, both online as well as through webinars. Please fill out the survey and give us specifics on what you'd like to do. Jennings, let me throw this one at you. Someone asked, what's the timing of the GERS release?
Yeah, we're hoping here by the end of 2023 we will have a first release of these of the GERS IDs for the themes that we currently have, which is transportation, buildings, admins, and places.
Great. Sorry, I'm trying to go through questions quickly here. Will there be a Docker image to download?
Not necessarily, I suppose, but I think there are some other. I think you have seen a couple out there for like setting up Apache Sedona and then connecting to the Overture Parquet files. So I think that hopefully, this ecosystem that we want to foster around this data is really this tooling that makes it easier to work with. So I think, as you said, Mark, a lot of these, what happens in the future is going to be informed by what this community deems necessary and wants, and ways that we can support that. So if that's something that needs to happen to work with the data, then hopefully we can find ways to support the community in kind of creating Docker images to work with particular libraries to interface with the data, but not necessarily currently on a roadmap, but open to discussion.
Great, Jennings, we're at time, and I'm going to ask just one more question that came in. Is the question was, will GERS be numeric with a emoji indicating that was a preference? But maybe you could just answer it in terms of, if people are interested in the development of GERS, where should they be looking?
Yeah, so on the on GitHub, I believe it's under the schema repository, there are some discussions about the design of GERS. We have been looking at GERS will be what will be 128 bits, and the first 64 bits are going to be the H3 cell ID. And we're choosing that. We're adding this kind of concept of a little bit of spatial to the ID, mostly to ensure that then we can have unique IDs on the remaining 64 bits. So there will be a little bit of information encoded directly into the ID itself, which will be place as defined by kind of that H3 cell ID at obvious various resolutions, depending on the type of data it is, as well as the theme will be encoded in there. And then the rest of the ID will vary depending on the theme and what really makes sense for that data. So we're hoping this will be very well documented as we develop this per theme. Yeah, numeric is not off the table. It's a question of what happens on the second half of that ID. As long as we are unique within each of these H3 cells, then we have a reference system that can be unique.
Great. We're at time, and thank you all for hanging in there. We had more questions than we were able to get to. But we will be coming out with a blog post summarizing and try and answer some of those questions in the blog post. So look there. You get a survey. I know everyone likes to click off and go on to the rest of their life, but especially if you have areas you'd like us to talk more about, please indicate that in the survey. These are an important way for us to kind of communicate in long form, and would very much like to do that. So with that, I'll close. Jennings, thank you very much for your time. Audience, thank you very much for joining and for your questions, and we'll sign off for now, and hope to come back with similar discussions in the future. Thank you very much.
Thank you.